I'm Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. Let me thank all the viewers and subscribers for watching my videos and posting brilliant questions. So last week I got many questions on this topic of exponential equations and logarithmic equations. I've compiled some to share with you. So here are 5 questions for you. I would like you to pause the video, copy these questions, solve them, and then look into my suggestions. So to begin with, we have the very first question, which is 3 to the power of 2x minus 1 minus 27 equals to 0. It could be solved very easily by comparing the exponents. The second question here is 3 to the power of 2x squared minus x minus 3 minus 1 equals to 0. The exponent is a quadratic equation, and that, when equated to 0, can be solved. The next equation here is solve 5 to the power of 2x minus 5 to the power of x equals to 20. Now this question can be solved using quadratic equations, right? You can substitute 5 to the power of x as some variable, and then you could solve this as a quadratic equation. The next two questions are a bit tricky. So I'd like you to think over it and then provide solutions. We might use logarithms to solve them. Now let's continue and see how to solve them one by one. Now remember, we are not using any calculator, so you solve these equations and provide exact solution. So in case you have to write solution in logarithms, just write it in logarithms. Let's take the solution of the very first question, which is 3 to the power of 2x minus 1 minus 27 equals to 0. We can take 27 to the other side. So we get 3 to the power of 2x minus 1 equals to 27. And we can write 27 as a power of 3, right? Then we'll have the same base. And we can compare the exponents. Perfect. So that is one way of solving exponential equations. You have to have the same base. So we'll call this as our strategy number 1. So we have same base. And in that case, what are we going to do? We'll equate the exponents. Now this is the most common strategy, and if it works, this is the best way to solve the equation, right? So, but all equations cannot be solved like this. If you're lucky, you get some simpler equations which can be solved in this fashion. So equating the exponents, we get 2x minus 1 equals to 3. And so that gives us 2x equals to 3 plus 1, which is 4, and x is equal to 4 over 2, which is 2. So we get our answer, which is x equals to 2. Now, in exponential equations, it is also a good idea to check your solution. So I will not check it at present. However, I like you to always check solution. Correct? So let it be a part of your doing. Let's take up the next question, which is 3 to the power of 2x squared minus x minus 3 minus 1 equals to 0. Now we'll apply similar strategy as we did last time. So we'll rewrite this as 3 to the power of 2x squared minus x minus 3 minus 1 equals to 0. Taking 1 to the right side, we get 3 to the power of 2x squared minus x minus 3 equals to 1. And what is 1? It could be written as any base to the power of 0, right? So we have 3 to the power of 2x squared minus x minus 3 equals to 3 to the power of 0. Now again, we have common base, correct? So we'll again apply our strategy 1 and get the solution. So we could now write 2x squared minus x minus 3 equals to 0. That's a quadratic equation. You can factor this and then solve. So factoring product, we are looking for negative 6. So you could write this as 2x squared minus 3 times 2, right? So minus 3x plus 2x minus 3 equals to 0. So we can take x common here to get 2x minus 3 plus 2x minus 3 equals to 0. And we get 2x minus 3 times x plus 1 equals to 0. That provides you two solutions. One is x equals to 3 over 2, and the other one is x equals to minus 1. Now, again, we have two solutions. I hope both of them are correct, but I would like you to verify, right? So I'm taking both as the correct solutions. I would like you to verify the solutions. So again, I'm writing here check for you. Perfect. So let's move on and take the next question. It's a good idea to check. Many times, the solutions which we get may not be uh, falling into the domain. And in a test paper, you might get such questions. So that is why I'm stressing so much on checking your solutions. Question number 3 here is 5 to the power of 2x minus 5 to the power of x equals to 20. Let us rewrite this equation. It is 5 to the power of 2x minus 5 to the power of x minus 20 as equal to 0. Now, we could factor this. 20 is 5 times 4, so we could write this as 5 to the power of 2x, or straight away, we can write this in the factored form 5 to the power of x minus 5 times 5 to the power of x plus 4 equals to 0. I hope you get this step, how I did it. Let me just do some steps here. It's kind of a product and sum. You could write the equation as p squared minus p minus 20 equals to 0, where p is equal to 5 to the power of x, correct? So if you do that substitution, you get this quadratic equation. And this quadratic equation could be simplified. Minus 20 is 5 times 4, so we could write this in the factored form, p minus 5 times p plus 4 equals to 0. So you could also do this after substitution as shown here, or you could directly do as I provided you with the solution. Both are correct. Okay, so well, this is preferred. I'll prefer this, right? For most of the students, that should be the step. Don't go direct as I did. So now we have two conditions here, and one we are saying that 5 to the power of x is equal to 5, then this will be 0. The other one we are saying is 5 to the power of x is equal to minus 4. Only then that will be 0. As you can clearly see, exponential functions are always positive, so that is not possible, right? So that is not possible, and therefore we'll reject that solution. However, this is correct. That means x is equal to 1, right? Because this is 5 to the power of 1. So we do get a solution which is x equals to 1 in this particular case. Remember, all the exponential functions will be kind of like this, right? So we have a positive value. Okay, let's take the next one now, which is question number 4. Solve the equation 3 to the power of x plus 1 minus 8 3 to the power of x minus 1 equals to 10. So this is where it becomes slightly tricky. So let's rewrite the equation. We have 3 to the power of, so we have 3 to the power of x plus 1. That means 3 to the power of x times 3, right? Times 8 into 3 to the power of x minus 1. Let's bring this here, minus 10 equals to 0. So that really means it is 3 to the power of x times 3 minus, this is 8 times 3 to the power of x over 3 minus 10 equals to 0. Perfect. Now, we can multiply by this 3, and so we get 9, 3 to the power of x, let's write this in brackets, minus 8, 3 to the power of x minus 3 times 10 will be 30 equals to 0, right? So that is what we get. Now, we can combine these two terms, 9 3 to the power of x and 8 3 to the power of x. So basically, we get 3 to the power of x minus 30 equals to 0. Right. So we can solve this particular equation. Now, can you tell me how are you going to solve this equation? Let's rewrite this on the right side, and then I'll provide you with the solution. So we have 3 to the power of x, and I'm writing 30 to the right side equals to 30. Now, to solve this equation, we'll take logarithms on both the sides, right? So take logarithms. So normally we take log to the base 10 on both the sides, log to the base 10 on both sides. Right. So we get log 3 to the power of x equals to log of 30. So which gives you x times, using properties of logarithms, log 3 equals to log 30. And we get x as equal to log 30 divided by log 3. Right? So that is how you could do it. Now log 30 could be written as 10 times 3, and you could further solve it and simplify this. So what I would like you to do here is also simplify your solution. Perfect. So you could actually simplify this solution a bit. So I'd like you to simplify this solution uh, and then provide the exact answer in a simplified manner, right? Remember, log to the base 10 of 10 is 1, okay? So let me write down. So we have log to the base 10 of 10 equals to 1. So you could use this to simplify your equation. Okay, that could help. So let's go to the next question, which is 3 to the power of 2x plus 1 plus 5 times 3 to the power of x equals to 2. How are we going to solve this? Well, this is similar to the previous example, and so I would like you to pause the video at this stage, answer this question, and then look into my suggestions. So what we have here is 3 to the power of 2x plus 1 plus 5 to times 3 to the power of x equals to 2. So this is 3 to the power of 2x times 3 plus this is 5 times 3 to the power of x equals to 2. Now that is a quadratic equation, right? So identify the quadratic equations. So this time what I will do is I will do the substitution. So we'll sub 3 to the power of x as, let's say, t. And then we'll rewrite and solve. So we have t squared times 3 plus 5 times t, bring 2 to this side, equals to 0. So now we can use sum and product to solve it. So we have 3t squared. 3 times 2 is 6. To get 6, we'll write here minus 6, that is. We'll write here 6t minus t, right? Minus 2 equals to 0. And we can actually take it to the right side and complete our solution. We can take 3t common. So we get 3t common from the first two terms. So we get t plus 2. And here we can take negative common to get t plus 2 equals to 0. Now t plus 2 is common, and that gives you 3t minus 1 equals to 0. So we get t equals to 2, and we get t equals to 1 over 3 as two solutions. Now, we are saying 3 to the power of x is equal to 2, or 3 to the power of x is equal to, sorry, this is minus 2. Okay, minus 2. 3 to the power of x is 1 over 3. Now, 3 to the power of x cannot be negative, so this is no solution. Perfect. However, here we have a solution, which is, we could think about it like 3 to the power of x equals to 3 to the power of minus 1. So the solution here is x equals to minus 1, and that becomes the solution for our question. Is that clear, right? So for exponential functions, the domain is all real numbers. So that works perfectly fine. So I hope with this you understand the concept of solving exponential equations. So what we have seen here is that we can use logarithms. So one strategy was definitely to provide with common base, and then we could equate exponents. So that was strategy number one. And second was use logarithms. Since logarithms are inverse of exponents, correct? So you could use logarithms. And third, we have checked for extraneous roots. In quite a few examples, we did have extraneous roots. We eliminated them because we knew that the y value is never going to be negative for exponential functions. So I hope that helps to understand the basic concepts involved in solving exponential equations. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching my videos and posting brilliant remarks. Thank you and all the best.